Yep, okay, so next up, so that's a nice little division proof right there. And by the way, now that you proved it, you can use that anywhere in your homework or tests or anything. It's very useful. Next up, let's prove this little ditty, which is, or prove or disprove, I should say. And the claim is I'll come back, I promise. For any integers a and b, let's look at how well. For integers a and b, if a divides b, come on. Oh, okay. No. Is there something else? Why? Sorry for the technical difficulties, everybody. Usually when I scribble, it just kind of comes back, right? Let's just pretend. I'll draw a smiley face. That's a haunting face. Oh. All right. Well, anyway, I'll just tell you what I said and we can talk about it while we wait for this thing to come back. And that is, I said if A divides B and B divides A, then A equals B. What do we think about that? There we go. Well, let's think about it. I mean, 3 divides 3, and 3 divides 3, and 3 equals 3. So there's some evidence there. But really, what we're kind of showing here is more the reverse direction. That, and maybe I should put that instead. Instead, I should put A divides B, then B decides C if and only if A equals B. So clearly, if A equals B, this works. For A divided by B and B divided by C, well, I mean, think about A dividing B. The relationship for A and B, you know, we kind of draw it out like we've been talking about a little bit here, right? Like, I don't know. Like this kind of diagram right here, I'm kind of saying that 4, 1, 2, 3, 4, divides 8. 1, 2, 3, 4, 5, 6, 7, 8. Because 4 can kind of evenly fit into 8. You can divide 8 evenly into groups of 4, right? That's kind of what this is saying. But notice if you're dividing a number into groups of other numbers, those other numbers, in a certain sense, have to be smaller, right? Those groups that you're dividing into have to be smaller or the same size, right? Because 8 does divide 8. But the point is it can't be bigger, right? Like you can't divide 8 into groups of 9, right? This is kind of making sense, right? You can't divide 8 into groups of 9. You can't divide 8 into groups of anything bigger. So if A divides B, I'll say then maybe, we haven't proved it yet, but then maybe A is less than B? If that were true, if true, then A divided B would imply A is less than B. B divides A would imply B is less than A, or less than or equal, I should say, right? Because like we said, 3 does divide 3. So if A divides B, then A is less than or equal to B. If B divides A, then B is less than or equal to A. Well, then together, if A is less than or equal to B and B is less than or equal to A, it's going to equal B, right?
Is that exclamation mark just a normal exclamation mark?
What?
Is that exclamation mark just a normal one?
Oh, yeah.
Okay.
Yeah. That's probably math. You can't get excited because the exclamation mark's used for like 3 different things. But yeah, so this is seeming to make some sense, right? And by the way, I mean, this just makes sense that A is less than equal to B and B is less than equal to A. The only possibility is that A equals B, but you can actually prove it because A is less than equal to B. What that's saying, that's equivalent to A is less than B or A equals B. And B greater than or equal to A is equivalent to, B less than or equal to A is equivalent to B less than A, or A equals B. And these two are kind of opposites of each other, so we can kind of use an elimination argument to prove that A equals B has to be true. But anyway, do we see any problems with this? Can you, because I said maybe, right? Can anyone think of a situation where A divides B, but A is not less than or equal to B?
The negative of number?
Negatives. Negatives totally screw us up, right? I mean, for example, 3 divides -6, but 3 is not less than or equal to -6. The exact opposite, -6 is less than 3. So that totally screws up this idea. But then wait a minute, this might lead us to a different thing, and that is what if we just use -3? 3 divides -3, right? Since -3 equals -1 times 3. We can find it's an integer multiple of 3. But also -3 divides 3. Since 3 equals -1 times -3. So this is our counterexample, right? This just shows right here that there is an A and B, 3, -3, for example, or you could use any two opposite integers like this. And A will divide B. Oh. This should have been B divides A. My bad, people. There's no C here at all. The point is, here A divides B and B divides A, but A does not equal B. So this is not true. We can't say this. Does that make sense? And by the way, we should have written it formally, which says that for all A and Z, and for all B and Z, A divides B and B divides A, if and only if A equals B. And so it actually is true that if A equals B, A will divide B and B divides A. We kind of talked about that a little bit, but it doesn't work the other way around. And for an if and only if to be true, like this is equivalent to saying for all A and Z and for all B and Z, A divides B implies, that this side implies this side, and then all of this and the other way. For all A and Z, for all B and Z, A equals B implies A divides B and B divides A. So it's an and statement, right? So to disprove it, you just need to prove that one of them's false. And even though this one's true, this one's false. So that's enough.